All right. So number 11, we're going to do these in groups of 5. Number 11, we have concentration of hydrochloric acid in a solution that is prepared, blah, 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 blah. We have a mass, we have grams, calculate the molality. So I'm not actually going to work this one out. We just need to convert those grams into moles and then divide them by the 0.200 kilograms. That one's pretty straightforward. It's not got any crazy tricks in it. Just change the 5.5 grams into moles and then divide it by the solvent. Good? All right. Number 12, mole fraction. So there are multiple gases going on here, so we're going to have to do a lot of little math. Lost my paper for a second there. A lot of little math. Convert each of these 3 gases into moles. So 4 grams of helium, the molar mass of helium is 4, so that is 1 mole of helium. We have 6.5 grams of argon divided by 39.95 grams equals, where am I? I lost my place. 0.163 moles of argon. What'd you say? No. Okay. And then 10 grams of neon. And neon has a molar mass about 20.18. So that is 0.4955 moles of neon. And then we've got all our moles, mole fraction of helium, okay? So that would be 1 mole of helium divided by the total, and the total moles are on my paper somewhere, 1.6585, and that's where I got the 0.60. So what's another way of looking at that? That is the mole fraction for helium. If I wanted to find one of the other ones, could I just subtract from 1 at this point? No, I couldn't, Calvin. Why not? There's more than 2. We'd have to find a second one. Maybe we went ahead and we find the neon. Neon would be like approximately 0.3, and therefore the last one would be 0.1, the missing one. Haban? Yeah. And if you have to find 2, you either have to do this twice, or you could, if there's only 2 gases, then you can subtract the 1 chi from 1. And again, I kind of look at this as it says that is 60% helium, 60% of the moles are helium moles, 30% of the neon moles, 30% of the moles are neon, etc. Let's see, number 13. Let's see, this is not Raoult's law. I know, Sam, it's Raoult's law, but I can't say that. And I know I just butchered that, and it's German, and my German's horrible. So it's just Raoult's law here, like Route 7. But anyway, Raoult's law, you know what, I'm going to clear all these moles off, if you don't mind, because I need the space. We have the pure pressure of ethanol, so that is P prime is equal to 0.459 atmospheres. Raoult's law predicts that the pressure is going to be dropped, so we're actually looking for the other pressure. Oop, don't put an X in there, that would confuse everyone. Put a question mark. In order to do that, we need chi. We need to know the chi of the solvent, or the chi of whatever we're looking for here. In this case, it is the pure ethanol. And so we got to take the moles, and this is, what's evil about this? It says millimoles. Does that matter, though? If they're all in millimoles, it doesn't matter. If they were indifferent, you'd have to convert them to be the same. So I'm going to say I have 90 millimoles of ethanol divided by the total, which would be 90 plus 10, so 90 divided by 100 total millimoles. So that's 0.9 for my mole fraction. So the equation is P is equal to chi P prime 0.90 times 0.459, and that's where we get the 0.413. Haban?
So from this question,
How do we know ethanol is the solvent? Well, there's two issues. We do have moles, yeah. I would probably take the moles in consideration. I have more moles of ethanol than I do of naphthalene. Plus the question's about ethanol. Questions like, what's the pressure of ethanol? The other big key here that I want to point out vocabulary-wise is that it is a non-volatile. This means no pressure from this substance. So that naphthalene is not turning into a gas. The naphthalene is not adding to the pressure above the solution. All of the pressure above the solution is due to the ethanol. Kayla.
He also assumes that ethanol is the solvent because it says you're going the naphthalene in ethanol.
You know, Kayla, I think you just made a very good point. It says that the ethanol is prepared by dissolving, so the ethanol is doing the dissolving. So that kind of implies that since the ethanol is doing the dissolving, it's the solvent. Yeah, Kayla, good job. Any other questions about 13? Uh, 14. All right, 14, vapor pressure question again. They gave us the molar mass of glucose so we could properly change the moles because they didn't provide the formula. But again, they've given us P prime. It's in torr. That doesn't really matter unless they have all the answers in atmospheres, which would be evil because then you'd have to convert it to atmospheres. But all these answers are in torr, so we're okay. We don't have to make the conversion. We need to figure out the moles of everything, which I have here somewhere. Oh, no, I don't actually have on my paper. Yeah. Molar weight, molar mass, molecular formula mass, formula weight, all of those things are interchangeable. In this case, they're saying the molecular weight, but it just means this is what 1 mole weighs, right? So 18 grams of glucose divided by a molar weight of 180 means we have 0.1 moles of glucose. And then we have 95 grams of water divided by 18.02 grams. I don't have that on my paper. How weird. Oh, is it 5.27? Yes, it is. 5.27 moles of water. So chi for water would be the 5.27 moles of water divided by 5.37. That 37 is the total of both of these. There's my chi. And then I could just plug that in and say the pressure would be chi, and I didn't simplify it on my paper, so I'm just going to leave it as this, times the pure pressure to get the pressure at this of this solution. And I think usually we see SOLN here, and that stands for solution. Yes, Haban.
So in the Raoult's law, right, there is no Van Hoff factor in the equation. So it doesn't matter if it's an electrolyte or a non-electrolyte. Does it really matter?
Yes.
The question has is a non-electrolyte.
It would matter. Let me just state Haban's question there. Haban, you okay, Matt? Good. Haban says, if it says it's a non-electrolyte and there's no Van Hoff factor, does that really come into play if it is an electrolyte? If it was an electrolyte, you would have to compensate for each of the little ions coming off because the moles of ions would be greater than the moles of compound. So let's just go back to our basic idea that if this instead, right here, instead of being glucose, or this had been sodium chloride, there's 2 ions in there, so the total moles would really be 0.1 sodium, 0.1 chlorine, which would impact that number just barely, wouldn't it? It would have made that 5.47 because you'd have had a 0.1 and another 0.1. No, Raoult's law does not have, or Holt's law, sorry Sam, Raoult's law doesn't have that extra 0.1 on it. It only has, it doesn't have the I factor, the, what do you call that, the Van't Hoff factor. It just has the chi. Maybe it should. You could write your own. Yeah, that'd be awesome. I don't know where you'd fit it in, though, because it would be down here in the bottom of the, in the denominator of the mole fraction, wouldn't it? But, yeah. Any other questions on that? Yeah. Always coming up with interesting ideas. Thank you. Oh, that's number 15, so it's time to stop the video.